Hi, welcome you all to my new lecture series on low temperature physics. My name is Jacob and I'm currently working as a laboratory facility manager at London Center for Nanotechnology. So in LCN, we have a common facility called QuEST, which is Quantum Engineering for Solid State Technology. And in this center, we are providing the low temperature environment for the users to come and do the experiment. So if you are from an academic background, or if you are from an industrial background, or if you're an experimentalist and if you want this low temperature environment, you can come to LCN and you can use the QuEST facility and you can do the experiments here. So if you are interested in doing experiments, you can contact me. I'll leave my contact details in the description, and you can do your experiments here at LCN. We will provide all the basic support for the experiments. And uh, in this lecture series, I'm going to share some of my experience in the cryogenic field, and also I'll be explaining about various techniques that we are using to achieve the cryogenic temperatures. So coming to the topic, the importance of temperature is not fully recognized by the mankind. This is because the organic life is restricted to a very narrow temperature scale. If you are looking at the temperature scale in the left hand side of the image, you can able to see the organic life is restricted to a very narrow temperature scale. But if you are looking at the temperature at the center of the hot star, which is of the order of 10 power 9 Kelvin, and also the lowest man-made artificial temperature in the condensed matter laboratory is 10 power minus 6 Kelvin. But the lowest temperature achievable in nature uh, is 2.73 Kelvin, which is due to the photon energy still being radiated from the Big Bang. If you are comparing the natural temperature, low temperature, to the artificially man-made low temperature, we have already surpassed the natural temperature by 6 to 7 orders of magnitude, which is a huge achievement, which is difficult in other branches of physics like high energy physics or high pressure physics. So we are already in a way advanced uh, stage of achieving our low temperature. The search of this low temperature physics started uh, because of two reasons. Scientists and engineers started exploring the low temperature for two main reasons. The first one is more practical one. That is because like people are started to uh, transporting the refrigerated meat from other continent to the Europe. Uh, so that is the more practical reason. And the second one is a more scientific reason. And scientists was trying to explore, is there any permanent gases which can always be in the gaseous state throughout the temperature range. So the later one, the scientific interest of the engineers, uh, they started exploring the low temperature physics, and people started to liquefy and solidify the various gases. And now we know the gases which is present in the atmosphere, the common gas nitrogen will liquefy at 77 Kelvin and solidify at 63 Kelvin. And the carbon dioxide will liquefy at 304 Kelvin and solidify at 195 Kelvin, which is commonly called as dry ice. And oxygen will liquefy at 90 Kelvin and solidify at 55 Kelvin. And if you are taking hydrogen, which can liquefy at 20 Kelvin and solidify at 14 Kelvin. So if you are taking different gases in the atmosphere, they are liquefying and solidifying at different temperatures. These liquefied gases are known as cryoliquids, and the liquefaction and solidification temperature of the various gases are determined by parameters like zero point energy, vapor pressure, and dipolar interactions, and various other factors that we are going to see it in details in the upcoming lectures. So in the next lecture, we are going to see the properties of cryofluid and what are the different parameters which is determining the liquefaction and solidification temperature of this cryofluid. So thank you all.